Are you overwhelmed with working on inverters or ductless mini splits? In today's video, I want to go over the 5 biggest tips that I would give any HVAC technician when working on this equipment. It is a little different than what we all learned on, especially if you've been in this trade for a while. When I got in this trade, we were working on equipment that was using the same technology that we had all been using for decades. The refrigerant may have changed, but all the single stage stuff pretty much has the same technology as the single stage stuff years and years and years ago. And so in today's video, I want to cover some of the tips that I would give someone working on these mini splits, ductless systems, and also today's inverter high-end, high-SEER equipment systems. And let's dive into this. So the first one is, I think it should be noted that a lot of these systems require, in some cases, different tools. Now, of course, we still need the same tools to take the cover off. We still need a meter, a multimeter to do a lot of our testing. But just know that a lot of these inverter systems, depending on what you are testing, what you are having to repair, you do need some extra tools, some tools that maybe you have never used before. Some of those tools might be magnets for the different solenoids and valves. There are magnets specifically for some of the reversing valves, and just know that a lot of the reversing valves on some of these systems are not your typical, 24 volts either on or off. Some of these have holding voltages. Some of these have high voltage solenoids. Other tools that you might need are EEV magnets. These systems don't have, of course, the old school pistons. Some of these inverter systems may have a TXV, but many of them have EEVs or some variation of such. It's an electronic expansion valve. It's got a solenoid on there, and you need an EEV magnet to be able to test that at times. You'll have to spin it around there to open or close that valve. Another tool that may seem basic, but you are definitely going to need is needle probes for your multimeter. Getting into some of these thermistors to test them properly, you're going to need needle probes. You're not going to be able to use your typical leads that would come with your meter. Another tool may be an ECM motor tester. Some of these testers can also test variable speed motors. It's good to have one of those to do a go, no-go test. And then finally, some of these systems, like we were a Daikin dealer at my company, and Daikin has specific tools that you can plug into their equipment to get readings that you would not be able to get without that tool and be able to get real-time data. And there's other brands that have tools like that as well. So just keep that in mind. Number 2, unlike working on a single stage or a 2-stage system where you're using AC voltage, you're narrowing things down at times, you test it, you replace the failed part, and you're off and running again. A lot of inverter systems, when a part fails, it can cause other parts to fail. And so I encourage a lot of folks that I help to test all components. If possible, if you can get in there, especially with your needle probes, and if you have, say, one thermistor that has failed, go ahead and test all the thermistors in that system really quick. Just go right down the board there and test them all. But the other thing I'll throw out there is we have seen where PCBs may fail, but something caused it to fail. So if you've got a board that's failed in there, make sure you test all your components, because say a motor, for example, if it failed, it could have caused that PCB to fail. And so again, you wouldn't know that without testing all of the components. I have seen technicians replace that board only to find out that the new board is now failing because that original part that caused all of this was never tested. Number 3 on tips, a lot of brands don't want you testing the refrigerant like you typically would. And so I know a lot of them have a way, for you to put the system into charging mode. But a lot of brands, especially if you go through their instructions, they'll even put in there, this is only for service. This is only to troubleshoot the system. If you're installing this system for the first time, factory charge is good for this length of line sets, and anything more than that, we want you to weigh it in based on this math. And they don't want you putting it in charging mode and dialing in the subcool measurement in a lot of cases. Now, I'm sure there's exceptions to that rule, and a lot of heating and air guys might comment on this video and tell me that I'm wrong about the specific brand that they're used to selling. But I bet a lot of those folks that might comment that, if they would go back and read the instructions, they would probably find as well that math, that equation, that formula when you are installing that system. They put that on there. They want you to weigh in the extra charge based on the length of the line sets. Number 4, I would say, depending on what the problem is, there is this problem in our industry where a lot of guys will think that the system is an inverter of some type and they think they can just slap it anywhere. It can ramp down. You can put it in an area where it's oversized and it's okay. And that is not the case. In a lot of cases, it's definitely not the case. And so we've got a bunch of pros in our industry that are running around slapping these systems in, and they're having some of the major issues that we would see any single stage system have as well if it were oversized. So short cycling issues, humidity issues, and on, because that system is oversized for the space that it was put in. I'm not saying you need to go do a load calculation every time you go to a service call. Do keep in mind, if you are servicing an inverter system, it could be oversized. It could be the reason you're having the problem that you are. Number 5, this one's pretty simple. Stick to the basics. I was helping a guy not long ago. We were walking through what his system was doing and just simply going back to the basics, the circuit of refrigerant, whether it's a vapor or a liquid in certain states, and why the system is doing this or that. We were able to decipher that the system was simply overcharged because of what the system was doing. And so sometimes just going back to the basics, understanding the way that system is designed to work, even though it has all these capabilities of being able to ramp up and down, communicating systems, being able to do all kinds of different communication. At the end of the day, it's still an air conditioner that's designed to do heat transfer on some level. So that's my big 5. But before you go, I want to throw an honorable mention out there. If you've got any concerns or tips that we haven't covered here, leave us a comment down below. I'd love to hear about that. And finally, my bonus tip, and this is a big one actually. If you're going to work on an inverter system, just know that a lot of those systems have a really high voltage on the DC that is sometimes being bled off by the capacitors when you first turn that system off. So it could have hundreds of volts, DC volts, stored in those capacitors that needs to be bled off before you get up in there. It's a big safety issue if you're not. And so simply turning off power to a system that was operating and waiting several minutes, 10 minutes, 15 minutes before you lay hands, get up in there, then that is one way. But also getting those needle probes out, testing on that inverter board, find the plus and minus, and make sure that it's gotten down to a safe voltage for you to work on. So that's my 5 plus 1. If you like this video, I think you'll like this one even more. It's where we talk about the expanded cooling data and dive into some things that a lot of heating and air guys don't keep in mind. Thanks for watching. Hit that subscribe button for more heating and air tips. We'll see you next time.